Hi guys, welcome back. Today is Friday and we're going to be talking about scientific notation and scientific calculations. We are going to start off today as we always do. You guys are going to do a do now / bell work / your attendance piece for today. Remember, you're going to go ahead and log into Socrative. If you're in my fourth block, you're typing ChemLewis 4. If you're in my sixth block, you're typing ChemLewis 6. And remember, when I ask you or when the site asks you for student ID, it really means your student ID number, like 1, 2, 3, 4, 5. Probably yours isn't 1, 2, 3, 4, 5, but type whatever yours actually is. So go ahead and hit pause at this time, navigate to Socrative, and come back. All right. So today's objective, we're going to be doing two things. We're going to be practicing two different things today. And the first is you should be able to use a scientific calculator. And you should be able to use it to complete calculations using scientific notation. So we're going to use lots of scientific notation in this class, and we will use a scientific calculator a lot in this class as well. So what we're going to do today is, after we do all this beginning stuff, do now objective agenda announcements. First, I'll talk to you guys about scientific notation. I know you probably have been taught scientific notation before. I'm actually kind of counting on that. This is more of a review to make sure that you guys remember your scientific notation, and we're going to get some practice with it just to make sure that you got it on lock. Then we're going to bust out our scientific calculator. You can probably see that I'm using that TI-30 that I really, really like. You might also be using something that's like a TI-83 or something. Say you're in like a fancy math class that needs a fancy calculator. If you have this, I'll show you how to do the stuff that we're going to do today on this. But you should only need one like this. And like I said yesterday, this is $8 or $9 on Amazon. So it's also at like Target, and even Fry's has them sometimes. So you might be able to get them at the grocery store. If you are using a phone calculator, remember what you're going to have to do is turn it sideways like this so that you can get this EE button. And remember, this is stinky. We don't really like using the phone because it's just not as intuitive and easy to use as calculators. But if you have to use that today, then that's okay. Just make sure you have your scientific calculator function on it. Announcements are, you are going to absolutely need this College Ruled composition notebook. On Monday, I'm going to set up your notebook for the semester. For the year, actually. You'll use this one notebook the entire year. You should be able to. Hopefully you won't run out of space. If you do, I'll let you know, but that shouldn't happen towards the end of the year, until towards the end of the year anyway. Remember that there's going to be a quiz next Friday, and that's your second graded assignment. It's not a second grade assignment, but it's the second graded assignment going into your gradebook. You can use your calculator, whichever one you'd like, on this quiz. Just know that it's going to go over everything that we've talked about from page 1 until page 5, I believe, is where we'll be on Friday. And then, as an update, your grades for careers in chemistry, that assignment is going to be updated today. So if you didn't turn that in, you will see an incomplete, and that soon turns to a 0. So make sure that gets to me as soon as possible. All right. So what we're going to be doing from here on out, I'm thinking that this might be an easier way for you guys to see my notebook. It's maybe by using this. Maybe we'll see, hopefully. Okay. So I'm going to pick up like basically where I left off yesterday. Remember yesterday we talked about measurement. And again, if you weren't here yesterday, what you can very easily do is you can find these notes by going to the virtual classroom. I've bookmarked my virtual classroom because you're going to be using it a lot. You may as well. And then if you have missed any notes, remember that you click on the notebook. And when you click on the notebook, it takes you to a shared folder in My Drive. Where you can access your notes. So we're in measurement and matter as a unit. You click here. Might take some time, sorry. And then I share with you every day the pictures of my notebook so that you can make sure, oh yeah, it wasn't here. I need to make sure that I get those notes. The advantage of the fact that I am like pre-recording these lessons means that you can just go back and watch the lesson, so that I know maybe measurement might not be something that's really confuses you, but when we get to things like mole conversions, you might be like, oh man, I really wish that I saw Miss Lewis explaining this. So it'll be good that you can go back and just watch the video of me teaching you how to do something, even if you were not like present that day. Okay, so getting back to what we're going to be doing today, because we're moving on to our second topic. Once again, what we're going to do every single day is, and we will start to use this left side. This is kind of going to be your side for processing. This is like your work side. This is where you do like a lot of lab stuff. Like this is like your side of the notebook. And then my side is the right side. This is where I'll give you that like direct notes, instructions, like what do you need to know about this topic in order to be successful. So today's topic again is scientific notation and calculators. Now you might be thinking like, okay, Miss Lewis, I've used a calculator before. I don't need a lesson on it. But it is critical that you guys are using your scientific calculator correctly, because we're going to be doing a lot of calculations with scientific notation. And again, if you don't plug it into your calculator right, it's just going to like give you a bad answer, a wrong answer for basically no reason. So I want to avoid that for you guys right off the bat. So again, put your date. Today is the 16th, 2020, which means we're 15 days away from Halloween. What? Okay, and so first we're going to talk about scientific notation. So obviously this is a science class, so you should be like, okay, I get why we might need to use scientific notation in a science class. But let me like emphasize to you guys why it is so important that we have scientific notation in chemistry specifically, because you may not have used scientific notation in maybe some of your other classes like bio. But let's talk about why it's so important in chemistry. So we're gonna start by talking about the mass of an electron. Okay, you guys probably know that an electron is that negatively charged particle in your atom, right? It's on the outside of the nucleus. It's actually like the most important piece of the atom in terms of chemical properties, bonding, like anything that like an element does, like reacts or bonds, is all going to have to do with electrons. So we spend a lot of our year talking about electrons. So how much do they weigh? Okay, well, they weigh point. Let me see for a second so I'm accurate here. Okay, you're going to have to write 26 zeros. 1, 2, 3, 6, 6. And then 9109. Okay, and that's in our SI unit, kilograms. Okay, so you should remember from yesterday that a kilogram is actually 1,000 grams. And we're going to start working with those numbers in terms of like mathematical computation starting on Monday. But again, 26 zeros and then 9109 kilograms. That's how much one electron weighs. Okay. Another thing that we use, and we have started talking about this as of yesterday, is the mole, right? We might be talking about a mole of atoms, which you should remember from yesterday is kind of like a chemistry version of a dozen, right? It's just a way for us to package atoms or molecules or particles of any kind, so that they're like manageable in terms of like a scientific, like an experiment or a chemical reaction, right? So do you guys remember the number for the mole? you should, because we did lots of Kahoot questions about it, right? That's going to be 602, and then 21 zeros after that. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so if I put little like commas there, that's kind of why I braced it that way. It's also easy to look at. So a mole of atoms is that many atoms. Okay, so in context of chemistry, we deal with really, 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 really small numbers. And we also deal with really, 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 really big numbers. And like basically for the same reason. Electrons weigh a very, very small amount. So in order to have like a gram of electrons, it would take a ton of them all piled together to weigh even close to 1 gram. So we deal with, again, small numbers and big numbers as a result of that. So it's much, 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 much easier for us to write these numbers in scientific notation than it is for us to write out all those zeros. Like I don't even know how many zeros. Like, I mean, I know how many zeros, but I've never really written them out that way, which is why I had to like pause and count and think about it. The way I typically write a mass of an electron is I usually write 109 times 10 to the negative 27th kilogram. Okay, that's a little bit more manageable in terms of writing that out, right? For the mole of atoms, I actually usually write, and this is what we wrote in our notes yesterday, we wrote 6.02 times 10 to the 23rd, right? So those numbers mean exactly the same thing. It's just way easier for me to write this one than it is for me to write this one. And that's why it's so important to use scientific notation in chemistry. And then we also need to be able to calculate with these numbers as well. So let me remind you of how you're going to convert to scientific notation. Or you're also going to be asked to go from scientific notation back to what's called standard notation. Okay, so if the number is written out long like this is standard notation. If it's written out with the times 10 to the exponent, that's going to be your scientific notation. Okay, so you're going to practice today going back and forth before we start doing some calculations with it. Okay, so here's going to be your steps that you're going to follow. Number 1 is going to be move your decimal until there is only one number in front of it. One is very important. If you ever have something like 11 times 10 to the 23rd, that's not correct. It should be 1.1 times 10 to the 24th. It should always just be a single digit in front of the decimal, okay? So you always want to be counting as you're moving that decimal because the number of spaces you moved is equal to the exponent in the scientific notation. Okay, so like what I mean by the exponent, you should remember that this number 23 is up high as a superscript. That's the exponent. The negative 27 is written up high. That's the exponent. Okay. So this is the part that you may forget or you may have got confused about before, but remember, like, it depends. Do I have a really, really small number or do I have a really, really big number as to whether you're going to have a negative exponent or a positive exponent. So you should be able to tell from my examples up here, the mass of an electron is really, 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 really small. It's a small number. So that's why we actually moved this decimal place to the right. And I have a negative exponent for how many times I had to move it. The mole of atoms, this number is actually really, 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 really big. So that's why I have a positive number, because I had to move my decimal all the way over to the left. And that's kind of like the key thing to remember here. So if your original number is less than 1, okay, so if it's a less than 1, like this is a very, very small number, then the exponent is negative. Okay, but if the original number is greater than 1, then that means your exponent stays positive. Okay. Hopefully for most of you guys, this is a review and you're thinking easy peasy lemon squeezy. If you're not thinking that it's a review and that it's easy peasy lemon squeezy, don't worry. We're gonna go through it a few times today to make sure you got it on lock, like I said. So let's do a couple of examples. All right, I want you guys to change the number 123,000 to scientific notation. Okay, 123,000. So remember, what we're going to do is, even though there's like not technically like a decimal present, you can assume in a whole number that your decimal's at the very end. Okay, so we're gonna move it until there's only one number in front of that decimal. So we would move it 1, 2, 3, 4, 5 times, and that's where I would put my decimal. So I know this number gets to be 1.23, and the fact that I moved it 5 times is what I'm going to say times 10 to the 5th. Okay, I have to determine then, is that going to be a positive 5 or is it going to be a negative 5? That's kind of your last question here. And because this number was much greater than 1, it was 123,000, that means I get to keep my exponent positive. Okay, what about the number point? Oh, and I'm sorry, I always box my answers so those stick out. Okay, and then point. Now draw 4 zeros, 7, 4. Okay, how would we write that in scientific notation? Well, once again, I want to move this decimal that's actually already present in my number until there, once again, is only one number in front of that decimal. So we would go 1, 2, 3, 4, 5. Okay, so it was 5 times as well this time. So my number would be 7.4 times 10, and then we write 5. But this time, however, the number that we started off with was 0.000074. So I know that that number is actually a lot smaller than 1. So that means we're going to have a negative exponent. So we're going to say negative 5th power for this one. Okay, so hopefully you can see the difference there. You should have seen that from your example problems up here as well. Now, the other thing I'm going to ask you to do in my practice just now is I'm also going to ask you to go from scientific notation, like 8.92 times 10 to the 3rd, to what's called standard notation, right? This is standard scientific. Now I'm going scientific, and I need you to do standard. Okay, so we're just going to follow the guiding of the scientific notation, and I'm going to say, okay, this one is a 3, so that means I need to move my decimal 3 times. It's positive, so that means that my original number is bigger than 1, so that means I'm going to move it to the right. So I'm going to say 1, 2, 3 to the right, and then that empty space becomes a 0. So my standard notation number should be 8, 9, 2, 0. Okay. Then another one that you might have to do would be something like 3.25 times 10 to the negative third. Okay, so similarly, we might have the number 3, but it might be negative. So remember, I am going to move mine 3 times, but because it's negative, that tells me that the original number is much smaller than 0. So I must need to put zeros in front of this number. So I'm going to take that decimal and I'm going to move it 1, 2, 3 to the left this time. And that means that I need to insert some zeros there. So my standard notation number is going to be point, and you can write 0 point. Either way, you'll be correct in your practice today. 0.00325. Okay, so in summary, remember that for scientific notation, we only want to have one number in front of our decimal. Okay, you always count how many times you're moving your decimal, and that becomes your exponent. All right, you have a positive exponent if your number started out very large. You have a negative exponent if your number started out very small. If you're moving to standard notation and you have a positive exponent, that means we're going to move the decimal to the right to make a big number. If you have a negative exponent, that means we're going to move our decimal to the left because you must have a very small number. Okay, so we're gonna pause the notes here. We will come back when we talk about scientific calculators, but what I want you guys to do for right now is you were assigned a Google sheet or Google form, I'm sorry, and it's titled Scientific Notation Practice. So I want to show you guys how I expect you to do this by giving you a free answer. So this first one is write the following number in standard notation. So you've got 5.3 times 10 to the third. Standard notation means that I would type in the right answer. Oh, I'm sorry, I'm not on the right. Here we go. I'm not on the right one. So I'm sorry. I'm glad that we got this one instead. Write the following number in scientific notation. Okay, so it's hard to write in scientific notation on a Chromebook, right? But what you can do is you can write 2.687, okay? And the reason why I put the decimal right in front of the 2 is because I only want to have one number in front of my decimal, right? And then if you want to just type this out, I'm fine with that. You can write space times space 10, and then you can write your little caret. And then what I ended up doing here is I moved it to I moved that decimal 3 times. So I would write 3. This is a perfectly acceptable answer. Remember that I want a space in between your time sign and then no spaces anywhere else. Or if you'd like to, you should see this little symbol right here. You'll probably see this symbol often in forms and things like that, so you might want to learn to use it. If you click on this little symbol, you will see this toolbar come up, and you can hit, oh gosh, this needs to move. Can I move this? Oh no. No, yeah, I can. Okay, so you need to hit this right here. And then if I wanted to type 2.687, and then I could hit times 10 to the third. I hit all the same exact buttons, but now it's written in the correct form, right? If I want to do it this way, and then I can just hit insert math, then my answer comes up correctly right there as well. So there's 2 ways to do this. You can either hit the spaces and leave your carets in your answer, or you can use the fancy tool that I've embedded in there. I suggest trying out that fancy tool because, like I said, we're going to be using it a lot. So finish this little quiz kind of thing that I have for you guys here. It shouldn't take you very long. You're going to submit it, and then you'll see instantly how you're doing. So you'll know if there's any questions you need to ask, or if you're on point and ready to move on to the next part of the lesson.